Right. Welcome, guys. Today I have an interesting question where some guys have been asking me, if I can help with how to articulate such equations. Like in this case, we have an interesting equation where 2 is raised to the power of x on this part, and we have a 2 raised to the power of minus x plus 2 and is equated to 3. So usually these type of problems, they are mainly solved by rearrangements. You apply your laws of exponents, and to some extent you apply logarithms, natural logarithms. Anything can take part when you come across such questions. But in this case, my preferred way is I want to rearrange first. So 2 to the power of x minus this part here, we only add powers according to exponents. We add powers if the bases were multiplying. So in this case, we have a 2 to the power of minus x multiplied by 2 to the power of this 2 here. That's how we got to this level. So now I've just taken it back and we equate it again to 3. So having this, we can see this 2 here raised to the power of a negative x, we can rearrange it to 2 to the power of x minus 2 to the power of 2 over. Why am I saying over? According to laws of exponents, when a number is raised to the power of a negative power, we can say 1 over that number raised to the power of the power given. So in this case, it's 2 to the power of x. Then I equate it to 3. I haven't changed anything on the equation. Please take note of that. I've just rearranged it to have it clearly, or to see it clearly. So in this case, I want to say a is equal to 2 to the power of x. Remember, when I say a is equal to 2 to the power of x, I just want to replace a 2 to the power of x. I want to put a in his place. Now, in this part here, we're going to put an a minus 2 to the power of 2. It's a 4 over an a, because we're now working with this one here. 4 over an a is equated to 3. We'll come back to this part as we solve this question. So I want now to solve this mutated equation. I want to solve it for a. So now I'm going to multiply the whole equation by a, just to get rid of this denominator, which is the a here. So if I multiply this whole equation with a, it becomes an a squared, because we've multiplied with an a. And when we multiply this part with an a, this a cancels the a we are multiplying with to leave us a 4 there. And we equate it to this 3 multiplies by an a, it becomes an 3a there. So remember, guys, this equation is our new equation we want to solve for a. So I'm bringing this part, this side, to the left side, and we're transposing it, and it becomes a negative, because each time we transpose crossing the equal sign or jumping the equal sign, the number changes the sign. So in this case, it becomes a squared minus 3a minus 4 is equal to 0. Now you can see this is a quadratic formula, but this is a quadratic equation, and we don't need to use the quadratic formula. But to those who are very efficient in using the quadratic formula, it's also advisable. You can apply it. There's no problem there, as long as you present your work carefully and show you're working perfectly. There's no problem in doing that. So now I'm going to look for two numbers that I can multiply to give me minus 4 and add them to give us minus 3. Those two numbers, as I can see, it's a minus 4. It's a minus 4 and a positive 1. If we can multiply minus 4 multiplied by 1, we get minus 4 here. And if we can add these two numbers, a minus 4 plus 1, we get a minus 3. So these are our perfect roots. So now the answer for a becomes a minus 4 bracket a plus 1, we equate it to 0. Then we now solve for x. It means a is equals to a positive 4 or a negative 1, because we are equating these factors to 0, both of them. So if we equate this part to a 0 and this part to a 0, you get answers for a become 4 and minus 1. So I'm going back to this part here where I equated a is equals to 2 to the power of x. Now, if I say I have a as a 4 and I have a as a minus 1, I'm going to try both of these two to solve for a in this one. Now we get to find x. So if I put a 4 here and equate it to 2 to the power of x, this equation becomes like now by inspection, I can see this 4 can be written as 2 to the power of 2 is equals to 2 to the power of x. It means if the bases are equal according to exponents, the powers are equal. So the first answer for x is equal to 2. This is the first answer. For the second part, I'm going to equate a 2 to the power of x is equal to a minus 1. Right. Now, I'm looking for a number that I can raise to the power 2 to the power of x. This becomes our second part for x. So a minus 1